Hey guys, Buildzoid here, and we're back with the Ryzen 7600X to look at some more memory timing stuff. Basically, the motivation for this video is that somebody on Reddit made the observation that AMD might not be using the, the tRFC same bank memory timing. And so I did some testing on that, and it looks like that observation was correct. You can set this timing to like 50 and the system still boots and it doesn't crash. It runs memtest. Like, that should not be possible. Then I was like, well, okay, if same bank isn't used, what are the chances that tRFC2 also isn't used? And so I set tRFC2 to 50. That's still booted, and we're gonna look at that today. And so I was like, okay, so tRFC2 might also not be used by the memory controller. And then there's tRFC. And if you set tRFC to 50, then your system doesn't post anymore, which makes sense because you can't refresh Hynix ADI in 50 cycles. Like, that's just not going to get finished. Anyway, but I wanted to sort of, like, testing whether or not something posts, like, was like, well, maybe the memory controller, like, doesn't use the timings if they're just set too low. So maybe the memory controller is really smart, which I find hard to believe because this is an AMD memory controller, but, we need to verify. So the next step is to see if those timings actually have any impact on performance, because if they don't impact performance in any way, shape, or form, then they're not being used, right? Like, if you can set them impossibly low and it posts, and you can also set them ridiculously high, and then like a sensible value, and then an impossibly low value, and your performance doesn't change, then those timings aren't real, and the memory controller doesn't actually use them. But the registers for them do exist. But anyway, so tRFC2 is at like 4,000, same bank is at like 2,000. Right now we're at just DDR5 4800, and the reason we're at DDR5 4800 is because if you want to exaggerate the impact of your memory timings, you need long clock cycles, right? Like, the whole reason why, as DDR memory progresses, timings keep getting looser and looser and looser, but the performance impact of those loose timings is less and less and less, is because the clock cycles are getting shorter and shorter and shorter. So for this test, we're at DDR5 4800, which isn't even that slow. We could have tried like DDR5 3600 or something, but pretty much all time, like, I've minimized most of the timings except for the tRFC2, tRFC same bank, and the refresh interval. The refresh interval right now is very short. It's set to 5,000 cycles, which I do believe is actually like more frequent than JEDEC spec. So we're like, from a performance perspective, what I've done here is really dumb, but I'm trying to like maximize the amount of refreshing that's happening. So anyway, I guess we should also try what happens if I set refresh interval to 65,000, because maybe that might force the memory controller to start using the same bank and tRFC2 timings, but maybe it won't. Anyway, if we run PyPrime, which is basically the greatest memory benchmark ever made, we're going to get a nice, reliable performance number. This is the benchmark I run when IDA spits out a number that doesn't make any sense. That's why I don't like IDA. It's like, anyway, we're going to have to close everything because PyPrime is unfortunately quite sensitive. It's not quite as bad as like SuperPy 32 million, which takes forever to run, as it is insanely sensitive, to the point that like your operating system is a massive problem. But yeah, PyPrime is a bit more robust in that sense, but it is still quite sensitive to, so running a bunch of garbage in the background generally isn't a good idea. So we're getting 11.68. I'm going to grab a random piece of paper to write these results down. We're going to get a slightly lower one, but yeah, 11.68, 11.63, and then we're going to hit one more time. Okay, I think this is going to be another like 11.6 something. So, yeah. And like, I really like PyPrime. This is a very good memory benchmark. Like I said, if I run IDA and it spits out a number that just like doesn't make sense, I run PyPrime to verify whether or not IDA is lying to me. And that's like the one downside to PyPrime is you do have to run it at like fixed CPU frequency, and you have to disable simultaneous multi-threading or hyper-threading because it's a bit less reliable if those two are turned on. Also, it tends to score worse. Okay, so we're getting about 11.58. So, we're in like that 11.6 to 11 point, like low 11.6, I'm going to call it, like around 11.6. So now we're going to go into the BIOS and we're just going to smash the same bank and tRFC2 timings. And the reason this isn't really that significant, or well, depends how you look at it. So the point of the like same bank refresh and the refresh 2 timing is that it allows you to refresh the DDR5 memory with like somewhat more efficiently. Like especially same bank allows you to do like a refresh on just parts of the memory chip. So you can potentially, I'm pretty sure you can still run like a read operation or a write operation at the same time as you're doing a same bank refresh, which is really cool. Because on like DDR4, you couldn't do that. On DDR4, if your memory was refreshing, your memory was refreshing. You can't access anything. So anyway, yeah, and so I have a very short refresh interval. And these two are now garbage tier. And actually, you know what? Maybe we should check what happens if I max out tRFC1. We should try that too. So what if we have like a ridiculously long refresh cycle? Oh man, this well we just like these settings that we have right now where it's like 5,000 cycles get used, like every 5,000 cycles we're going to spend 4,000 cycles refreshing. Our memory is going to be so slow. This might double the calculation time. Okay, no, it won't actually double the calculation time, but it might get close to doubling the calculation time. Spending 4,000 cycles refreshing after every 5,000 cycles is going to be very slow. And also, actually, I want the postcode. Hopefully this doesn't cause any post issues, but it should be fine. Like, there are some timings where if you set them too high for certain memory chips, it might cause, like, issues, but refresh really shouldn't be one of them, because as far... Yeah, Yeah, I don't think there's, like, a refresh confirmed of any kind. So it's basically just the memory controller says, hey, memory, please refresh yourself. And then it waits, and waits, and waits, and keeps waiting, because we've just set the refresh interval to 4,000 cycles. So it's just like, yeah, I've never done this. So I do wonder what this is going to do to performance. This is going to, like, it should be a complete disaster. It should be very, very slow. I mean, we can already kind of see the system being very slow, but let's verify in Ryzen Master. Or I wouldn't say checking your timings with software is a good way of verifying that your timings are actually applied, but at least the CPU says that it's going to wait 4,000 cycles. Oh yeah, it basically doubled it. Oh, it's so slow. Oh man. It hasn't crashed. Oh my god. 20 seconds. That can't be right. Oh wait, no, because previously we spent what, like, every 5,000 cycles we would spend 500 cycles refreshing. And now, every 5,000 cycles we spend 4,000 cycles. Wait, is that... Because we're getting like a 10x increase in calculation time. I don't think we only have memory access for 1,000 cycles. Unless, like, I misunderstood how refreshes work. Or, like, in how refreshes are timed. Because I thought the refresh interval starts at the end of the refresh, not like... Because this right now looks to me like it's from refresh to refresh. Right? Instead of, like, refresh, 4,000... You wait 4,000 cycles, then you wait 5,000 cycles, then you send the next refresh. This right now, like, based on what it has done to performance, I would say we go refresh, wait 4,000 cycles, wait 1,000 cycles, refresh, wait 4,000 cycles, wait. Oh, I hit the HDMI cable. Oh boy. Okay, yeah. So I guess, huh. Well, that makes the calculating the performance impact of the refresh interval somewhat more convenient. Yeah, that literally slowed it down by 10x, which I was not expecting. I was expecting it to double, but it might have actually. You know what? I do have the Infinity Fabric at 2066. It might have glitched. There's like a weird, wacky glitch that you can get with the Infinity Fabric once it's above like 2,000 megahertz. Which doesn't really tend to happen at high memory speeds, but at low memory speeds, you can end up in this weird situation where the Infinity Fabric runs at like 1/10 speed. Usually it's because it's unstable. So yeah, I should have actually run all of these tests with just like 2,000 Infinity Fabric. That's what I get. This is also why you shouldn't max out the Infinity Fabric before you max out your memory. You should max out your memory first and then do the Infinity Fabric, because if you go the other way around, you can end up with Infinity Fabric settings that cause random performance regressions that, yeah, aren't fun to deal with. Worst case scenario, I've just learned that my understanding of how refreshes are timed is completely wrong, at least for AMD memory controllers. I don't know, maybe Intel uses a slightly different... Actually, no, I don't think they have a choice in that. It would probably have to be implemented. Because here's the thing, right? Like, the memory chips are really dumb. So if you tell the memory chip to do something that it physically can't do, it'll still try to do it. So that's why that's why there's not really like a lot. There's not a lot of hard rules for memory timings, because it's like just because something is like you can basically tell the memory chip to do whatever. It may or may not be able to complete whatever you asked for. Anyway, let's run PyPrime again. Hopefully it doesn't run at 1/10 speed. If it does, then evidently my understanding of how refreshes are timed is a bit off. Actually, not a bit off, like way off, but normally it isn't a problem because your refresh isn't like 80% of your refresh interval. Okay, yeah, looks like I'm just completely wrong about how refreshes work, and it wasn't the Infinity Fabric bugging out. Well, that's nice to know. So we've learned something today. Refresh cycle is a portion of your refresh interval. It's not added on to your refresh interval. Because like my understanding was like refresh interval, then refresh cycle, and then another refresh interval. But evidently how this actually works is like you send a refresh, and then... Wait, so if you set your refresh interval below your refresh cycle, your memory will literally be inaccessible. Yeah. So don't do that. You'll never be... Like, your memory will literally just only be refreshing. You'll never be able to do anything. Okay, so we don't need to run this. This is evidently super duper slow. What's kind of funny about this is, like, I've literally just reduced the memory performance of this system to, like, 1/10 of what it is, and I can't really tell until I try to run a benchmark. Like, the mouse... Admittedly, I'm going through a capture card, so you know the mouse isn't the world's most going through the capture card and like looking at the mouse movement in OBS isn't exactly the world's most responsive experience. But yeah, like it didn't feel any laggier than it usually does, so that's fun. Anyway, so the refresh cycle timing definitely has a drastic performance impact, especially if you set it to something stupid like 4,000. So we're going to put it back down to something sensible like 500. Wait, actually, no, I really... No, we're going to set it back down to 500. And now we're going to do refresh cycle number 2. We're going to set that to, let's say, 300. Right? Actually, we're going to set that to 400 and 300. And we're going to use these two numbers because these are like the numbers that I put into my easy timings for Hynix memory chips video. So I imagine this will actually perform exactly the same as the numbers we got with 500, 4000, 2000. If it does, then it means the memory controller really doesn't seem to be using those refresh timings. And then we're going to set the refresh interval to, refresh cycle to 50, 50, 50 for the, actually just 50, 50, not 350s. We're going to just set the tRFC2 and same bank both to 50. And it probably won't change performance again, which would indicate that those two timings just don't really get used by the memory controller at all, which would kind of indicate that AMD's memory, you could argue that like AMD's DDR5 memory controller isn't fully featured, because it like doesn't use the same bank refresh option, which is a really like on a theoretical level, same bank refresh is a really cool idea. You don't have to refresh the entire memory stick every time you want to refresh anything, which can have like drastic performance improvements. Then again, with Ryzen, the Infinity Fabric is kind of a massive memory bandwidth bottleneck anyway, so does it really matter if your memory controller isn't as efficient as it could be when it's ultimately connected to something that's way, way, way slower? Yeah, so now we're getting basically the same performance as before. And PyPrime is a very, very like sensitive memory benchmark. That's why I like it so much. Yeah, so we're getting like 11.7. The thing is, right after the system boots up, there might be like stuff running in the background, so rerunning it a few times. 11.6, yeah, 11.7 again. So, you know, we did it like one of the first runs that I did previously was 11.68. So we're kind of in that same range right now. It's a bit slower. 11.69. This is the one downside to like very memory sensitive benchmarks, is they're unfortunately a bit inconsistent. 11.6. Yeah. Okay, so now we're getting down to that like low 11.6 range. And it's interesting that the first calculation steps in this are like kind of slow, and then like it speeds up more towards the end than the ones we did at the start of the video. Oh no, this one's just slow across the board. Oh wait, I didn't close Benchmate. Oops. Stop. There. Okay, now we're going to run it without Benchmate. Oh yeah, so Benchmate has like a bunch of monitoring that it runs in the background to verify that you're not cheating on benchmarks. Or more like to verify that Windows time hasn't like broken, which is a real concern. Windows is actually very bad at maintaining reliable time tracking. So, like, I think at the start of the video, I ran it without Benchmate in the background. Yeah, now we're sort of in that 11.6 to, like, 11.5 range. I mean, there was also 11.515, but close enough. So, I would consider that margin of error. Right? We're talking, like, yeah, like, I'd consider that margin of error. What, like, tenths of a second on a 10-second score? That's, like, 1%, right? Yeah. I'm not that bad at math. Actually, I am. If I was better at math, I probably wouldn't run a YouTube channel. Anyway, so yeah, so lowering the refresh to same bank doesn't really affect performance. So now we're going to go all the way down to 50 and see what happens. Like, the first indication that these probably aren't used is the fact that we can even post. Because on an Intel system, if you set your same bank refresh timing super low, the system will just crash. Like, we do spend some time memory training, which I think is just because every time you change the memory timings, the BIOS tells the CPU, hey, retrain memory. Also, I was really hoping this video wouldn't end up like half an hour long, but I see now that I was wrong about that. Stupid Ryzen memory controller. Also, like, I'm quite upset that I had a totally like incorrect understanding of how like refreshes are timed. Like, the funny thing about it, it's not really a problem unless your refresh is, like, basically, like, your refresh interval is basically the same as your refresh cycle. Which is how I never noticed. right? Is like when you're like, because normally your refresh cycle is like a tenth of your refresh interval. Like it's really short. So, changing it doesn't really affect performance very much, or doesn't affect performance that much. And so it isn't really like, so, it's not something that you just kind of like realize that, oh, wait a minute. Yeah, but when your refresh cycle and your refresh interval are basically the same length, that starts being a major problem. Yeah, it didn't change, like, at all. So those timings really don't seem to be used at all. Yeah. The memory controller just doesn't use tRFC2 or same bank refreshing. So that's nice to know. Now, if you're wondering why, like where I got the 500, 400, 300 from, that's basically the kind of settings that you would use like with an Intel CPU. Well, Intel actually doesn't implement the like regular tRFC value, if I remember correctly, or something like there's a difference to how Intel handles their refreshes compared to AMD, but yeah, so 500, 50, 50 doesn't cause issues. So next we're going to try 400, 300, but we're going to max out the refresh interval. And this will drastically speed up pi prime because the less time you spend refresh... Actually, will it? Yeah, no, we're going to go from like 10% of our refresh interval being used by the 500 cycle refresh to 1% being used up by the 500 cycle refresh. So the reason I'm doing this test is like, well, maybe the memory controller only uses same bank and tRFC2 if the refresh interval is like massive, but I kind of doubt it. I think those two timings just aren't used at all. Well then, let's run pi prime again. This time it's going to run way faster. Yeah. The difference that spending 10% of your available clock cycles refreshing compared to like 1%, less than 1% of your available clock cycles refreshing. It's a roughly 10% speed up, which makes sense. Also, this benchmark is very memory latency sensitive, and the reason why like your memory latency comes way down as you reduce the amount of time spent refreshing is because if you send a read command, like if you, or I shouldn't say, you won't, like the memory controller won't send a read command until the refresh cycle is complete. So if you send a refresh command for the next like 500 cycles, you can't read or write or anything, right? So for the next 500 cycles, all of your operations take forever, basically. And so your average memory latency is worse the more time is spent refreshing, right? Because when you're not refreshing, your memory latency is the same as if your refresh cycle, like going, like if you have, like for 4,500 cycles, your memory latency is your TRCD plus, well, depends what state the memory is in. So we're actually just not going to do that. But the basically the difference between like high refresh interval, like a long refresh interval and a really short refresh interval is that if you have a really long refresh interval, your latency is shorter. Most of like you have like normal latency for longer than if you have very frequent refreshes or if your refreshes are really long, because there's like periods of time where your latency is just through the roof because you have to wait until the refresh completes. Anyway, so that's like 10 seconds now. I'm going to call that 10.1. And I'm sure if I adjust the poked myself with the pen. If we adjust the same bank and tRFC2, nothing's going to change. It's still going to be like 10 seconds. And yeah, I mean, the nice thing about this is, like, you have less stuff to do. Downsides of the Ryzen memory controller. There's a lot of restrictions on your timing, like what timings you can adjust and how much you can adjust them. Like, you can't set TWR below 48. The memory controller doesn't let you go any lower than that. But the upside to the memory controller not letting you set TWR below 48 is that a lot of DDR5 memory chip, or at least Hynix DDR5 memory chips, definitely do TWR 48. Like, that is not a problem. You can just set 48 TWR and not think about it. It's fine. So, you know, not having to set your, like, tRFC2 because it's not being used and not having to set your same bank because it's not being used is like, well, that's just less work, right? You don't have to spend as much time tuning all of your memory timings if two of them don't actually do anything. At which point you might be wondering, but why do those settings even exist? Ask AMD. AMD, you know, makes the AGSA. AMD is are the ones who reveal the memory timing registers to the give access to the timing registers to the motherboard manufacturers. So, like, why does tRFC2 exist? Somebody at AMD might know, but evidently it doesn't seem to be implemented on current AGSAs. Maybe in the future they might, like, enable these two, like, refresh modes. And then, like, if you punch in 50, it won't post anymore. Or something. But yeah, right now it really looks like those two timings just aren't used whatsoever. Which is fun. Oh, I forgot to close Benchmade again. Oh, well, it'll be fine. Yeah, so we have that, like, Benchmate penalty, so we're just going to close that. Yeah, it's the same. It's about 10-1. So yeah, same bank refresh and tRFC2 are just not being used at all. Neat. That solves that mystery. And also, if you're wondering, like, well, what about tRFC? Is tRFC used? Yeah, and I can prove it. Because if we set tRFC low enough, it won't post. Right? Because, like when I realized, wait a minute, I can set tRFC2 to 50, it's like, does tRFC actually do anything? And, I mean, we also saw that, like, setting tRFC to 4,000 just tanks performance, which was fun. So, but yeah, if you set it to 50, like, the system will not post. So, like, 15 is, like, that's the memory training. So, during the memory training, the memory timings aren't really going to be used. Well, until certain parts of it, but, or, like, the refresh timings aren't going to be, like, too important. I'm pretty sure the refresh timings, like, the refresh timings that you have in the BIOS during memory training are just not actually, like, being used. And now that memory training is finished, we get stuck on A6 because the moment the memory controller needs to refresh the memory, it can't. Or more like, the moment it sends a refresh command and then 50 cycles later tries to do something, everything breaks. So yeah, we get stuck on A6. I haven't checked if it'll actually auto-recover from this state. It might not, which would be kind of annoying, because to cut the 5-volt standby in order to get the clear CMOS to work on this board. Yeah, okay, it won't recover. Well, anyway, yeah, at this point it's just a clear CMOS to get the system to post, and I think I've shown everything I wanted to show. Evidently, tRFC2 and tRFC same bank are not used by the Ryzen 7000 memory controller at this time. This might change in the future. Maybe some later IGSA update will like get the memory controller to start using those timings. But as of right now, those two timings don't do anything. And so if you're tuning your memory, you can like just leave them on auto, you can put them to 50. It'll look really cool in screenshots to anybody who doesn't understand what the memory controller actually does. It's like one of the fun things with certain memory timings is you can punch in arbitrary numbers. You can set them to 1337. You know, get some leet memory timing screenshots out of it, because yeah, those two timings don't actually do anything. So that's fun. tRFC does. tRFC does affect performance, but I'd argue like fiddling, really trying to dial in your tRFC when you can just set refresh interval to 65,000. Why bother, right? Like, yeah, you're going to see a small performance improvement going from like 500 tRFC to like 450 tRFC, but the big improvement is going to be going from like, because default refresh interval is like 8,000 or 10,000. It's like somewhere in that range. If you go from 10,000 to 65,000, your refresh, like the amount of time your memory spends refreshing goes from like 10-ish% or like approaching 10% to like 1%, if even that. Right? You could literally have a tRFC of 650, and that would be 1% of your 65,000 refresh interval. So, yeah. Now, the one concern with maxing out the refresh interval is if your memory sticks get hot, then you're going to have data corruption. But also, like, if you use a somewhat lower TREFI, like 50,000 or 32,000, you're still going to get a big performance speed up because of that pretty drastic reduction in refresh like in the amount of times being spent refreshing. But you're also going to be much more resistant to high operating temperatures. So yeah. Anyway, that's fun. We don't need to worry about the tRFC2 and tRFC same bank timings on AMD memory controllers because they don't do anything, at least for now. It would be really annoying if in the future AMD re-enables them and this video ends up just being completely wrong, or like Ryzen 8000 might get a revised memory controller which does use those timings, or some APU that's monolithic has a memory controller that does use those timings. It could also be a matter of like AMD deciding to, just maybe this current memory controller can use those timings. The AGSA just doesn't use them in its current configuration. So, yeah, anyway, that's like, so the information in this video is not, time proof, but at least for now, you can basically use those two timing registers as like random, like you can just punch in whatever the hell you want because it doesn't matter. Anyway, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, hoodies, posters, the usual YouTuber merch. And yeah, that's it for the video. So, oh, I forgot to mention I also have a Bandcamp. And yeah, that's it for the video. So thank you for watching, and goodbye.